here in example 5, you're going to find a cubic polynomial function with real coefficients that has 3 and 2 minus I radical 2 as zeros, and f of 1 is equal to 6. You're going to want to write either small or leave quite a bit of space, and you might have to write below on your notes. This will take up quite a bit of steps, but I want to make sure I explain it thoroughly, that way you don't get lost. So if we are going to have a cubic polynomial function, that means you're going to have an f of x equals a. This a is going to come into play at the very end. So actually, let me make this a different color because we're not really going to mess with this until at the very end. So I'm going to write as a different color, and I'm going to kind of disregard it for now. But if you have a cubic function, that means your roots would be x minus p, x minus q, and x minus r. And p is going to be 3, q is going to be 2 minus I radical 2, r, well, we're missing one. Well, if 2 minus I radical 2 is a 0, that also means that 2 plus I radical 2 is going to be a 0. So when we write our answer, f of x is equal, and then I'm going to just put like dots down here as we go down for a. Then we're going to have x minus 3, x minus, now q is going to end up being 2 minus I radical 2. And then for the second one, or the last one, the r, we're going to have x minus, this is going to be 2 plus I radical 2. That was not given to us, but we know that if we have a complex root, we're going to have 2 roots. Alright, so the big thing is, this looks a lot worse than what it is over here on the right. You can rewrite this stuff so that you have, you can rewrite them as difference of squares. So I'm going to have this equal, and then x minus 3. And inside this bracket here, what we're going to do is we're going to put this, in brackets, and we're going to have x minus 2. And if we distribute this negative through both of these, this ends up becoming a negative 2 and, or sorry, a positive 2 and a negative. Sorry, both of those end up changing here. So yeah, negative 2 and a positive, so that should be right. So this would be negative 2 plus I radical 2. And then over here on the right side, this becomes x minus 2. If you distribute the negative through, minus I radical 2. Basically, all they do is just this parenthesis becomes this one, this parenthesis becomes the left one. Nothing really changes. Now the big thing is you want to group two of these together. You want to group together the x minus 2, and you want to group together the x minus 2 over here. And what we've done is now you have a difference of squares. The two terms in parentheses, those are the same. I radical 2 plus and a minus. So this is helpful in simplifying. Instead of having to multiply all three of these terms by everything, all over doing all that multiplying, you can actually do this shortcut with a difference of squares. So this x minus 3 is still kind of hanging out in the front, and you're going to end up with x minus 2 squared minus I radical 2 squared. Alright, well, I'd like to say we're almost halfway through, but we're only about a third of the way. I know, it's painful. X minus 3. Let's simplify what's in the brackets. This becomes x squared minus 4x plus 4. Over here, minus, now if you have an I squared, that's I squared. But if you take radical 2 squared, that is just 2. Now remember, this I squared, back here in the back, becomes a negative 1. So if that is a negative 1, we cancel that out and make this negative 2 a plus. That is how you get rid of your I. And that's what we're trying to do here, is get rid of our I. So you get x minus 3 brackets x squared minus 4x, and then you can take this 4 and this 2 together, and you get right here. Now you still have this a that's been coming down the, been moving on down here. Going down, still coming down, still coming down, still going to come down for a little bit further. So we have equals x minus 3, or sorry, actually what we're going to do is we're going to take this binomial times this trinomial over here. So we're going to take x times all three of these. So x times x squared is x to the third minus 4x squared plus 6x, and then you got to distribute the 3, the negative 3, so negative 3x squared plus 12x minus 18. Once again, we simplify everything. So we get an a out front, x cubed minus 7x squared plus 18x minus 18. Alright, so we've done the most difficult part. Unfortunately, we still have this a and this f of x and everything to simplify. What we're going to have to do, that is where this f of 1 equals 6. This is where this is going to come in handy, because we're going to use this. This is going to help solve for a. Let's go to the next page. Whoops. So if we have f of x equals a times parentheses x to the third, and I already forget, minus 7x squared plus 18x minus 18, if f of 1 equals 6, we need to plug in 1 for all your x's, and for f of x, we're going to plug a 6 in there. So we're going to say 6 is equal to a times, we're going to have a 1 squared. So actually going to make this a bracket. So we're going to have a 1 cubed, sorry, minus 7 times 1 squared plus 18 times 1 minus 18. So just simplify your equation. 6 equals a times 1 cubed is 1 minus 7 is negative 6, and these 18s just cancel out. So you end up getting a negative 6 inside here. So if we divide both sides by negative 6, you get a is equal to negative 1. And what you're going to have to do with this a equals negative 1, you're going to have to plug it in front of your polynomial. And if that's a negative 1, all that's going to do is just change all of your signs. So if you have f of x equals negative 1 times x cubed minus 7x squared plus 18x minus 18, then your final solution, finally, I'm almost out of breath, negative x to the third plus 7x squared minus 18x plus 18. So that is your final solution. Finally, we are there. And trust me, why do you need to know this? Oh my gosh, I use this every single year, at least 3 times a year. So make sure you understand how to do this, because there may be some day when you can be like your uncle or your idol, Uncle Klein, and you'll be using this all the time. So I hope you enjoyed that example as much as I did. I've got a little writer's cramp now, and hopefully I need to stretch after this.